Well, I just thought I'd take an opportunity to show my quick and dirty 24 volt setup. This is in the bee shed, and as such it's sort of been prone to more improvisation and just, you know, lash the thing together. It's almost a test rig really, but I'm soon going to be doing a tidy up job on it, so I thought I'd just record it how it is, and just to show what you can do if you just want to throw something together quickly, you know. And it's been working fine for months. So this is what we have. We'll start off with the batteries. These are 150 amp hour AGMs. I've got 4 of them. Those 2 are in series, those 2 are in series. The 2 sets are parallel. Nothing unusual about that. Good battery bank. And at the moment the inverter I'm running off this is just this little 1000 watt inverter. Ignore this charge controller, it's part of a different system. And I am doubtful whether this is a true 1000 watt inverter, but it's actually been a very good inverter because it's got a very low quiescent current, so it is really good if you want it just sitting there live waiting for loads. It doesn't take too much off the batteries. It's quite an efficient one, but that's just clipped on with the old crocodile clips, so you know, hardly a situation I want to leave forever, but it's been like this for quite a while and I haven't had any problems from it. Okay, the solar panels come in through the wall here. There's a drip loop and stuff on the other side, but I've just bored a hole straight through the wall of the shed and stuck the cables through. As you can see, they all come down here. There's a few different solar panels. There's 2 80 watt polycrystallines that come down through these cables. There's a couple of 15 watt amorphous ones come down through them. This is a 50 watt panel, 12 volt panel, which is feeding that other charge controller, so it's not part of the 24 volt. And this is the new ones I put up the other day. Actually a 50 watt poly and a 50 watt mono in series to make 24 volts, which is a bit naughty, but it works fine. And speaking of naughty, what other things have we got here that are naughty? All the positives go together into this circuit breaker. It's a 16 amp circuit breaker. It's just a normal AC circuit breaker, but at these voltages it'll commutate the connection perfectly fine. I have never had any problems with using AC circuit breakers on low voltage DC, but I would never ever use one on high voltage DC. It'll just arc and melt down like thermite. What else? Charge controller. Now here we go. Now this is a contentious issue. This is a 12 volt charge controller, but yet it's running a 24 volt battery system. It is not one of those flasher ones that can switch and determine whether it's going to run in 12 or 24 volt mode. It is a full-time 12 volt charge controller. Little baby thing. Look how cute. Look how cute it is. So I've done a stunt that a lot of people think is quite dirty. And what I've done is I've tapped my battery bank so that this is only reading the voltage of one 12 volt battery, so therefore it thinks it's connected to a 12 volt system. And the way that's done, positive of all the 24 volt of all the solar panels comes through and combined in the breaker, as I said, and this wire here connects directly over down here to the positive of the batteries. Okay, so it doesn't go to the charge controller at all. And bear in mind, one important thing to note, that this is a common positive negative switching charge controller, as a lot of the cheap little sort of Chinese ones are. And if it was a negative common and positive switching controller, the configuration will be a bit different. So all the positives go to the positive of the battery bank. Now the negatives of the solar panels are all combined here in this little contraption. I don't think I have to say too much more about that. All the negatives are combined and they go to the negative solar input. And the negative battery terminal, battery output I guess you could say, goes of course down to the negative of the battery, no issue. But however, here's here's where the trick is. The positive of the battery input, instead of going to the positive of the whole battery bank, it goes to a tap in between, and I'm using this clip here. This clip is just connected to this blue wire, and you can see the nature of it being temporary, hence there's clip leads. So that just taps. So essentially this battery here is determining the state of charge for the whole bank. And there is a school of thought that this situation is very, very bad, but in actual fact it's not. It's not. But there are a couple of caveats with it though, and I'll try and explain this without making this too long-winded, but if it does get long-winded, forgive me. Okay, the main issue people have with doing this kind of thing, sampling one battery in a bigger system, is that say that sampled battery goes bad, you'll probably wreck the rest of your batteries. Now that's true, that is completely true, there's no disagreement here, and I'll show you why. Well, we've got a 24 volt system, let's just pretend it's just these two batteries. Right, so what will happen when these get charged up to about 14 volts is the charge controller will start regulating. Well, it's only when this battery will, and of course because these are in series and receiving the same current, we are assuming that this one here will also be at 14 volts, and that's fine. So as long as the battery that you're sampling is in good nick, then the whole thing will work perfectly fine and nothing will be any the wiser. Oh, incidentally, I will say the amount of current that goes down this positive here is actually milliamps. No actual charging current ever flows down this wire, only voltage from the battery goes back up, so this charge controller can read it. But anyway, now what happens though, let's say all of a sudden this battery develops a bad cell. So instead of being a 12 volt battery, it's now a 10.8 volt battery. Okay? Now, in a normal system, if this was being connected to a proper 24 volt charge controller, when the voltage got up to 28 volts, the charge controller would start regulating. Now, but let's suppose this battery is faulty and one cell's gone down, so it's behaving a bit low. Well, what will happen is the charge controller will still be looking for 28 volts, but instead of getting it from each battery as 14, this one will probably reach 12 volts while this one reaches 16, and then the charge controller will start regulating. So as you can see, the dud battery, even in a normal proper system, would be starting to cause the good battery to be overcharged, but only overcharged by 2 volts. So if you get it quick enough, it's not going to do it too much harm if you get it quick enough. However, the bad thing about doing this whole sampled arrangement here is that because we're only relying on this battery, if this battery never gets to its termination voltage, say 14 volts in this case, what will happen is the charge controller will never cut off. So this one may rise to 16, but then it'll just keep rising and rising and rising, because this one will never get to a termination point. If it does, of course it's fine, but let's say it's got a dud cell and it never does, well, the charge controller will just go on forever. As long as there's juice from the solar panels, it will just keep charging and charging, boiling and boiling away at this one, and it will wreck it. So there we go, that's the conclusion. So the conclusion that I have in my view on this is quite simple really. You can do this and it works fine, and you could even do it for a 36 volt or bigger battery bank, but you should keep an eye on your batteries often, because that battery that is being the sample battery, the one you're taking the reference from, you want to make sure that that battery doesn't go faulty. And as long as it doesn't, everything will work hunky-dory. Yeah, so there we go. I think I've said it now. I think I wanted to say this before. So this is the valid technique if you really need to get a 24 volt bank going and you only have a 12 volt charge controller. Or you could get a 48 volt bank going with a 24 volt charge controller. But in fact you could even do a 36 volt bank with a 24 volt charge controller. But those batteries you're sampling, you've got to be damn sure that they're in good nick, or you will wreck the rest of your bank. Like I say, I haven't had any problems with this setup, so it's all good. Awesome, eh? Well, this is what I'm going to be changing, so this is what I've focused on there. I'll just briefly show my other setup. Oh, this is battery bank F, by the way. Battery bank F. And this is battery bank G. It's just a bunch of old starter batteries that I've got connected up through this cheap Chinese charge controller here to a 50 watt panel which comes in here. And I just keep this basically just topped up for emergency power. I used it through this inverter the other day to run our lights just as a health run, and it works very well, since it spends most of its time trickled and hardly ever discharged. The fact that these are automotive batteries is neither here nor there. They're all second hand and they're all reasonably good condition for their second handness. Currently all this actually runs though permanently now is what we call the ding dong controller, which is my first lighthouse or lawn lighthouse controller I built back when I first came up to the North Island. I started working on this, but I've got a different one now, a much more sophisticated one. But this still controls the ding dongs, which is just a doorbell alarm which we've hooked up to this. In fact, there's the transmitter there, sitting up there on that old monitor. And when the sun goes down, it trips the trips the doorbells for a few rounds, and it's basically a warning that the sun's going down. If we didn't already notice, then we hear the ding dongs. It's a good time to get the washing in, and it also signifies now the end of the useful solar day. So, and this was running from this power supply underneath on the grid, but no, it's not. It's running from this white wire directly from these batteries here. So there we have it, a quick and dirty lash up, which works fine, but I'm going to tidy this up soon. And I'm also doing away with this one. I've got a nice charge controller now, a 15 amp one I think, does proper 24 volts, and it's got an LCD screen. Won't that be lovely? Yeah, so that's what will be in here, and I'm going to put it all on a board, which I will show you when I do it. So I think that's enough for now. This video is quite long, and it was a little bit long-winded.